goes this way, side to side to side to side. They slide past each other. Okay? That is a transform boundary. Divergent boundaries move apart. Think about when you divide something. What are you doing? You're splitting it apart, right? You're dividing it into 2 pieces, 3 pieces, how many people came over for pizza, whatever. Okay? When you divide something, you split it into many pieces and you pull it apart. Okay? So divergent boundaries go apart. So in our convection cells, right, they come up and they go apart. That is a divergent boundary. Okay? Our last one then is a convergent. Okay? If everyone converges in one area, they all come together, right? Say we all converge in the parking lot, all right, whatever. You are moving together, okay? Make sense? Yes. All right, so transform, divergent, convergent. Check, check, check. Got it? Okay. All right, let's talk plates. This should look hopefully very familiar. Color-coded a little differently, but plate placements look similar. Like, oh, yeah, I've seen that before. All right, the difference is they've drawn in the arrows as far as which way plates are moving, okay? So, if you look on the coast of North American plate and the Pacific plate, do you see how one arrow is going up and one arrow is going down? What kind of boundary is that? Transform. That is a transform boundary. Okay, what do you notice from last week happens at that point? What do we have a lot of?
Friction.
Friction, which causes earthquakes. What do you have a lot of in California? Earthquakes. Okay, so that helps explain why we have so many earthquakes there. Okay. Here's your Pacific plate and your Australian plate coming together. All right, so the arrows are going this way. What kind of boundary would that be? Convergent. Okay. And let's see if we can find, where would you find a divergent boundary between what 2 plates? You guys have this map, yes? All right, tiny, I realize, but can you find a divergent boundary for me? Eli, where would I find a divergent boundary?
The North American plate and the Eurasian plate.
North American plate and the Eurasian plate, right up here, yes?
Yeah.
Okay, moving apart. Our 2 arrows are going apart from each other. Okay, so there's a divergent boundary. All right. Now on our geochronology map, this was the area that we were seeing as far as that big, right? So this one right here is happening right here. What kind of boundary do you notice is both along these plates? It's all divergent boundaries because the seafloor is pushing apart. Okay, so you got new rock in the middle, old stuff on the outside edges. Make sense? Is all this starting to kind of weave together from last week? A little bit? Okay. All right. This map is also in your book for your reading tonight, so you'll see this again too. Okay. Let's talk about when plates collide. Okay. So you ever see those TV shows that's like when animals attack?
Yeah.
Okay, today we're going to do when plates collide. No? Yes. New movie coming out. See it. March 2014. Alright, so what happens when plates collide depends on the density of the 2 plates in question. Alright? Density has to do with whether an object will do what or what? Go up or down? Rise or down, rise, sink, float, up, down, descend, however you want to think about it. Okay? Alright? So, let's talk oceanic plates. Oceanic plates are more dense. Okay? They have more, they're kind of down here. Because what's on top of them? A whole bunch of water. Right? An oceanic plate is holding a whole bunch of water. Okay? It's more dense. So as far as where it's sitting on that magma layer, it's kind of doing a little bit lower than everything else because it's holding all that water. If you had to lug that much water around, you'd probably be like this too. Okay? A gallon of water is what, 8 pounds? I want to say? Something like that. It's heavy. Alright, continental plates then on the flip side are less dense. Okay? Continental plates are less dense. They are not holding all that water. Alright? So, in our first battle round, ding ding, in this corner we have oceanic. In the other corner we have continental. Okay? Title round. Okay. Our oceanic plate, because it is more dense, is against our continental plate, which is less dense. Okay? So now you've got more dense and less dense. As they come together, what's going to happen?
They're going to more dense, she's going to die.
I heard it from Elise. Okay? Our oceanic plate is going to subduct into a trench. And remember from your map, trench, we found a trench off the coast of Japan.
Mariana's Trench.
There you go. And there was a little blurb off the coast of South America, right? Those pink areas on our elevation maps, yes? Okay, so we're going to get a subduction zone. And remember that plate, that oceanic plate, is going to go back into the mantle, remelt, become ooey gooey again, and hopefully come out elsewhere. It's like Mother Nature's recycling. You just reuse it and reuse it and reuse it. Question?
When the oceanic plates subducts, does it take the water with it?
The water still kind of stays on top. Good question. All right. All right. In our second title round for the afternoon, morning, afternoon, whatever. We've got an oceanic plate versus an oceanic plate. So now we have two plates that are both more dense, right? We've got two plates that are kind of both dense because they're holding all of that water. Okay, here's the deal. The older one, so this has to do with age, my geochronologist.
That's me.
Okay, that's you. All right, the older one is going to be subducted underneath the younger one. The older one is a little bit more dense because it's been around longer. So think about it, grandma versus, right, the teenager. Grandma's probably going down, unfortunately. Okay, so or Alex?
So what happens when the book is made?
Oh, good question.
They just go like that.
Well, one of them's probably slightly younger or older.
They're exact.
Okay. Then it's a tie. Up is a different story. Let's get to up right now. All right, so in our last title round for today, we got a continental versus a continental. Okay? Unlike oceanic ones that are more dense, continental plates are less dense. Okay, so we've got two less dense plates coming towards each other. All right, here's what happens. They're not going to sink because neither one of them is very dense. Okay, so we don't have sinking or subducting going on. Instead, we get another land feature being formed. Mountains.
It's convergent.
Because it's converging together, they're not going to sink, so what else do they have to do? They're going to go up, and we're going to form mountains. So the Himalayan mountains between the Indian plate and the Eurasian plate, what kind of boundary is that? Convergent, divergent, or transform? Convergent. Those two plates are coming together, pushing up, and we get mountains. Huge ones, right? Alex?
How are places below sea level formed that are on land?
Run that by me one more time.
Like places on land that are below sea level, how do those work?
Like that are below sea level?
Yeah.
Could be erosion, right? If it's been scraping out. So you've got a river going through and it's scraping out things that's going below sea level. As far as I know, there aren't very many places that would fit that bill. There's a couple. It's not going to be totally prevalent. Yes? You have one in mind that you're thinking of?
Death Valley is on the most level.
Okay. But that's like the only one, yeah? It's not like they're all over the world, yeah? Yeah, they're pretty rare. Okay. Alright, now here's the thing. If you want to go out and observe your plates moving, I'm going to tell you it's not going to be that exciting, okay? It's pretty slow, which is why most of us, for the most part, don't realize that the plates are moving, right? Because if you think about what's, Pangea was 250 million years ago, that's a while, okay? Alright, so our plates grow about as fast as your fingernails grow. And if you've ever sat down and tried to watch your fingernails grow, I'm guessing you got bored after about 30 seconds, right? You're not going to see very much happening. Okay, it's about 2.5 centimeters a year. That's like this much in a year, okay? So it's pretty slow, which is why we don't realize it. We don't notice it. There are exceptions to this, however, especially if you live in places that are more prone to earthquakes, okay? Because think about it, at a transform boundary, if there's a catch and it's pushing and it's pushing and it's pushing and all of a sudden you get a release in pressure, you get an earthquake and you're going to notice that, right?
Yes.
Okay, but for the most part, our plates move at about 2.5 centimeters a year, which is not a lot. Yeah?
Could they move faster at some point without an earthquake?
I'm sure that's probably an average, Alex, but so at times they might go a little faster, at times they might go a little slower, but the average is about 2.5 centimeters. Okay. All right. Good? Good. All right, I think that was it. All right. Moving. Okay. So, for this evening in the gun, we've got a couple things, and it is the weekend, yes. You got a little bit of book 42 through 47 in your textbooks. Your fossil safari that we started yesterday is due on Monday. Alright, so most of you, I'm hoping, got to the point where all of your data is assembled and maybe you're starting to work on your questions. That is due on Monday. Okay? Alright, one other thing I want you to be aware of in your binders on page 15, 16, 17, 18. What's on page 18? No, 19, 20, 22? Yeah, that one. What page is it? 20? 20. Alright, on page 20, believe it or not, Brain Pop actually has a book besides the videos that they go out. So on page 20 in your binders is the plate tectonics page from the Brain Pop book. Alright, that goes along with what the video is showing you today. It's a good reference as far as the information. So if you're like, what was Tim talking about? You can go back and check out this page as far as the book is concerned. Alright? And I've pulled stuff from this book before, so some of it looks familiar. There's some lots of, like, most of their videos that they have, they actually stuff with it. Okay, so just FYI. Alright? Questions for today?
Sorry.
Okay then.